Okay, so hello there everybody, and welcome back, or should I say welcome to your very first upbge tutorial. I'm going to be teaching you the basics of the Blender game engine, at least the new one that's been maintained up to version 3.0. We're going to do the basics for a couple tutorials, and then we're going to make a video game. So, in the last video, I just told you to download version 0.3. I kind of showcased version 0.36 accidentally. I didn't mean to do that. But either way, get version 0.3, and I will teach you how to make a video game. Okay, so before we begin, I just wanted to give a quick demo of what's possible. So you're going to see here with only 4 nodes, and yes, we're going to be using node networks to make our game. There's a couple alternatives, but that's what we're going to do. With 4 nodes, we get something like this, a very complicated simulation that would be kind of hard to make in just default Blender. But this is something we can control and turn into a video game somehow. So just so you know, cool things are possible with only 4 nodes. And before we begin, I know, long exposition, I just want to mention there's a couple ways to use Blender Game Engine. One is using nodes, that's the one I'm going to be talking about. Another one is using the Logic Bricks editor, which I'm told is slightly faster performance-wise, but I don't care, I like my nodes, it's worth the slowdown for me. And then the third one is obviously scripting in Python, okay? So you can see there's a whole bunch of Python stuff over here. I'm just going to be talking about the nodes. Plain and simple. Let's begin. So, you can see I have a new file of upbge version 0.3, and it should look something like this. In the last video, I just said to make sure you have all your add-ons installed. If you don't, go to Edit Preferences, Add-ons, and then type in Game, and you're going to see a whole bunch of game engine stuff. The main ones I care about is enable logic nodes, and also enable Save as Game Engine Runtime. This is going to let you use your nodes. This is going to let you actually export your game. Let's make something. Enough chit-chat. What I'm going to do is I'm going to open up a new window, and once you have that add-on enabled that I was talking about, you're going to see something called the Logic Node Editor. Just like in Geometry Nodes, we have the Geometry Nodes Editor, and the shader, you get the point. We have a Logic Nodes Editor, and we can create node trees that make certain game behaviors, okay? So with this cube selected, I'm going to make a new node tree. I'm going to call this one Movement, because what I want this to do is basically move the object. Now, right now, this is just a blank node tree, not really applied to anything. You might think it's applied to the cube, but it isn't really, okay? If I go to this object properties and stuff like that, you can see it doesn't have any game properties, which is to say it doesn't have the node tree. So, first thing to do is you're going to see a whole bunch of stuff over here. Dashboard is the one we kind of care the most about. In Dashboard, you're going to see something that says Apply to Selected. So I'm selecting my cube, I have the movement node group, and I'm applying to selected. And you can see immediately we get a game properties thing. It's called logic nodes underscore movement, okay? And it's enabled in some sense. So in other words, this node network belongs to the cube now. So anything we do will work. Only other thing I'm going to do is I'm going to click Compile All. And I guess we kind of want to do that every time we compile the game, every time we run a new version of the game, although it kind of does it in the background, okay? So far, super simple. I've applied a logic nodes group to this cube. To get this game running, and this game doesn't have anything right now, but to get this game running, in the 3D viewport, you're just going to click P. P for preview. And now we're in our game. It doesn't do anything. So you hit escape, and you're out of the game. P for game. Escape for escaping out of it, okay? There's a couple settings that we can use when we're actually running our game, again, with P, and that's going to be in the render engine. By the way, this only works with Eevee, so keep this on Eevee. You have your resolution, full screen, yada yada. We can enable certain settings like mouse cursor. When I have this enabled, when I hit P, you can see the mouse cursor is above it, whereas if I don't enable it, the mouse cursor is gone. So some games use the mouse cursor, some don't. There's a lot of stuff here. I think the only one I want to enable is frame rate and profile. When I do this, you're going to see on the top left corner, we get all these stats, which makes me feel good. You can see the game's running at 60 FPS. And I guess I'm going to enable mouse cursor so I can just show you what's going on. 60 frames per second, and you can see a whole bunch of stuff, okay? Let's put something in our node tree so our cube does something. In the last tutorial, I hinted that there's actually a template for this, for movement. And that is, if you scroll down here, there's a prefabrication. You can just hit 4-key movement, and it's going to add a bunch of nodes. We're going to talk about what these do, and we're actually going to make this ourselves in this tutorial. But you can see we have a bunch of nodes. When W is pressed, S, A, D, this is WASD movement, okay? So now, if I compile this and hit P, you can see I'm now using WASD, and this is a game now, kind of. So I'm using WASD on my keyboard, okay? This isn't very fun because we didn't make it ourselves. So if I get rid of this and I run this again, now it's not doing anything. So let's make the simplest fucking game that we can make, okay? So just like we had in our example, we can look at certain things, like if a keyboard key is being pressed, if the mouse is somewhere, hit Shift-A, and you can see all your nodes. And there's a whole bunch of them. But I want you to start off with your input. So what am I inputting? I'm inputting in a keyboard, and there's a whole bunch of options here. I'm going to use key down, okay? So Shift-A, input, and I'm saying is a certain key down. Well, which key? I'm going to do press and choose, and now I can hit anything on my keyboard. I'm going to do spacebar, and now we're asking ourselves, are we tapping the space key? I'm just going to hit this again, so we want to know if I'm holding the space key down. That's what key down means. So if I'm holding spacebar, it's down. When I let go, it's up. And when this happens, we can do all sorts of things. So let's say we go into our object properties. We can do stuff with parents. Let's do something with visibility. The easiest game we have. You're going to notice that when we have this key down node, we have a red output. Red means conditional. You can see there's a condition right here. Just like in the shader editor and the geometry nodes editor, there's like green, purple, gray kinds of data types. Red means conditional, pretty much. So if I connect this to this, you can see it works, okay? So what we're saying is when we have the space key put down, then kind of go into this node, okay? And I want to have this be not visible. In other words, we're going to hide the object. And which object? The cube, okay? So what does this node network say? It says the moment that I put the space key down, it's going to set the visibility of the cube to not visible. So I'm going to hit P to run my game, and then I'm going to hit spacebar, and it's gone. And it doesn't come back because it's not saying that when I let go of it, it comes back. It just says the moment I click it, it does that. But what if we want this to come back? So when I let go of the space key, we want it to be visible. So this is where the logic comes into this. This is why it's the logic nodes editor. So the logic for this is when I hit the space bar, it's going to be invisible. And then I want it to be visible when I let go. So I'm going to have a new set visibility. I'm going to make this one visible. And instead of connecting this right here, which is going to kind of create a weird like loop situation. When I hit spacebar, it doesn't really know what to do because I'm saying both be visible and invisible. What I'm going to do is in the logic, I'm going to use the word not, which is to say negation, the opposite of. So instead of if the space key is down, when is it not down? And when that's the case, make it visible. Okay, so I'm going into my game, P to go into my game. I'm clicking spacebar, it's gone, and I'm letting go. Hitting it, letting go. So basically what we have is as long as we're clicking the spacebar, it's going to be invisible, okay? Very simple network. We can get even more complicated than this. So you saw in our logic, we have not, we have or, yada yada. I'm going to use an or. So instead of if the space key is pressed, let me have two options. Let's have the space key and the H key. H for hide. I'm going to connect both of these and put it in the conditional. What does this mean? This means that if I hit the H key, and let me just get rid of this for now. If I hit the H key or the spacebar key, or either one, it's going to make it invisible. So spacebar, it's invisible. New instance of the game, H key, invisible. Okay, so you can see how you can build logic. And in some cases, if you want like a keyboard shortcut, we'd use something like and. So if H key and spacebar are clicked, only when both of these conditions are met, make it invisible. So here I'm hitting space, nothing happens. I'm hitting H, nothing happens. I hit them together, and now it's gone, right? So this is how you can make like a Control-Shift-T kind of shortcut, yada yada. And now we have the basics to actually get this thing to move. So basically what we want is we know when we have a certain input, like the W key, we want it to go forwards. So instead of the visibility node, we're going to use a transformation node. So At some point, you'll get used to the names of all these. I'm not even used to the names of all these. But under objects, transformation, we have all these kinds of things. Some of them are physics-based, yada, yada. We can either move it to a spot, which is to say set the position. We don't want that. We want to adjust the position. So we can either apply movement or translate. I'm going to apply movement. And you can see the difference, just so you're curious. Here's the difference. Okay, this one has like a speed parameter and stuff like that. There, you could use either or. I'm just going to use this one for now. There's a lot of ways to do certain things. So let's say when the W key is pressed down, for the cube object, we're going to move it, well, it kind of depends what we want forward to be. I think I want this direction to be forwards, which is to say going positive on the y-axis. So I'm going to hit 1. So when the W key is pushed, apply the movement to the cube of going 1 unit on the y-axis, okay? So I'm going to hit P, and now I'm going to hit W. And you can see it's moving. It's moving very, very fast. So I'm going to set this to 0.1, making it 10 times slower, hit P, and now you can see it's moving much slower. So I'm hitting and not hitting the W key. But we have an issue. If we go too far forwards, it's off the screen. So wouldn't we also like to go backwards? Yes, yes. So there are ways to combine this in kind of like a clever way. I'm just going to do the simplest case, okay? So for backwards, I'm going to use the S key for WASD. When we have this, go backwards by negative 0.1. And notice that we can have multiple like node sections that aren't connected, okay? It's going to run all of these. So we're going through this until it's done, and we're going through this until it's done. They don't necessarily have to be connected to each other. So now I'm hitting W forwards and S backwards. If I hold it down, it goes smoothly. If I do it staggered, it's going to go staggered, okay? Just so you know, there are clever ways to do this. So if we wanted to combine both of these, how would I do that? Basically, I want to say, in one case, go up by 0.1 on the y-axis. On the other case, go down by 0.1 on the x-axis. Very weird. To do that, we can actually run this through some math. And this is where it gets weird. You can convert one data type into another data type. Sometimes that works, sometimes it doesn't. But in this case, it will work. So what I'm going to do is I'm going to take our key down. And the way I want you to think about this is when the key is down, when I'm hitting W, this condition is equal to 1. Otherwise, it's equal to 0. 0 means off, 1 means on. So if I take this and I subtract away this S, okay, and then I take this and I know I'm going to be talking about some nodes we haven't talked about yet. I know you're fresh to this. But if we go to math, we go to vector. Actually, I guess I want to go to values and I want to go to vectors and I want to make a x, y, z vector. Basically, what I want to do is I want to control the y-axis. So I'm going to connect that and connect that. So let's try to read what we're doing here intuitively. And by the way, we don't want this to be the condition. We want this to always be the condition. So under events, there's all kinds of events like saying the condition is met on every frame or only on initialization. For now, we're going to do on update. Okay, we're going to talk about what that means. But the way I want you to think about this is we have an apply movement. When is it going to happen? All the time. You can tell by this play button. On every frame update or every update in general, it's going to apply the movement. What kind of movement? Well, if we're hitting the W key, we're going to go up on the y-axis, and when we're hitting the S key, we're subtracting, so it's going the other way on the x-axis. And I might have these flipped, but let's see. P, okay, so it's working. It's going very, very fast, so I'm using W and S. So just like before, I want to scale this to 0.1 instead of 1, so I'm going to take this, and by the way, Node Wrangler doesn't seem to work with this, so I have to kind of connect it manually. Kind of a bummer. But I'm going to multiply this by 0.1. So now I hit P, and W and S work, but they go much slower. Okay? What if I want to move left and right? Let's just copy this logic. And some of these nodes we don't necessarily need to reuse. In fact, let me show you two ways to do this. So the first one is we're going to kind of create the same situation over here. Instead of up and down, we're going left and right on the x-axis, and that is going to be D and A. The reason D is first is I want that to be the positive, and A is subtracting, so it's the negative. We'll see if that works. So I'm hitting P, W and S work, A and D work. Now, those clever among you probably thought to yourselves, oh, you could combine those nodes. That's the case. And I guess whenever you can combine nodes, you should do it, because I feel like it's less computation. So instead of using all this, let's just connect this to the x-axis. So yes, we have all our keys. Yes, we have all our scalings, but they all go to the same vector. So W, S, A, D. Now we live in a three-dimensional space. Why don't we also have an up and down? Okay? How would we do up and down? Try to think about it before I show you. I'm going to add another section. I want up to be the up arrow, and you could use any key. I wonder if you can actually use a keyboard shortcut. I don't think you can. So I have the up arrow and the down arrow, and this is going to be connected to the Z. Now what does this do? It's going to give us three-dimensional movement. So W, S, A, D, up, down. Okay, so if we're navigating in three-dimensional space, that is how you'd want to do it. Now, of course, we're not used to that as a convention. We kind of use the mouse to kind of say where we're looking, right? And we do have options for that. So in the input, instead of the keyboard, we can also look at a mouse and a gamepad. But we're going to look at the mouse, and we can say when certain things happen, you know, whatever. Just so we have a bit of this going on, let's say when we're hitting the left button on the mouse, and we can set this to happen once. In other words, you can only click one time, and then it's going to stop being true. Or we can have this be on each frame, so anytime we're clicking the left button, what we can do is let's do the same thing as before. So now that we know the node, we're going to do set visibility. I'm going to connect this for our object, and I'm going to say when it's clicked, make it not visible, and then like before, we can do the negation. We can do the negation and hit not, and connect that and make it visible. So whenever this is clicked, right, whenever this is true, make it not visible. Whenever it is not clicked, make it visible. Okay, so what do we have? We have W, S, A, D, up, down, and when I click, and then when I let go, we can hide and unhide. So already we have a bunch of controls. Now, it turns out there's all kinds of properties you can change. You can even have some of these keyboard inputs change materials and stuff like that. Like everything's interconnected, okay? But basically what I wanted you to pick up from this tutorial is you can create node networks that control things. What's very important is for the object you have, you got to make sure that it has this as a game property. Now we could have just as easily added in a torus, and this isn't going to do anything, right? So I hit P, our torus is in the game, but we're only controlling the cube, right? But what I could have done is for the torus, I can apply to selected, and now this also has the game property. So think to yourself what's going to happen when I play this game. You might think that everything's going to move, which makes sense, except, no, why does only the cube move? Think about it. Well, if we go into our node network, you can see our movement is only being applied to this cube object, okay? And this is only being applied to the cube object, yada yada. There are two ways to get around this. The first one is instead of cube, we can hit this button, which means use owner. What does that mean? That means for the object that has this network, apply it to that. So instead of explicitly saying the cube, we're going to say pick yourself, pick yourself, pick yourself. And now when we play this, you can see that everything's kind of moving together. The way I want you to think about this is both of these objects have this movement node group, and for that node group, we're saying look at yourself. So that's going to mean different things for different objects. But the moment I disable this game property, what's going to happen? Only the cube's going to move.